VLSos here. This is a video lesson for geometry on similarity. Similarity informally means shapes that are the same but different size. Same shape, different size. And I put this in quotes because it's a good way to think, but it's informal. What similarity means, if two shapes are similar, then it more precisely means that corresponding angles are equal and corresponding sides are proportional. Proportional, not equal. So similarity says something about a relationship between two shapes and their sides and angles. In these two triangles here, we might be able to prove that they are similar. We would need some angle and side information. We could put an arc to suggest that angle A and angle Z are equal to each other. Two arcs here to show that B is equal to angle X, and angle C is equal to angle Y. These triangles may be similar. They don't have to be oriented in the same way, meaning this triangle, you can think of it as spun upside down. The shapes can be similar, but they don't have to have the same orientation on the page. They just need to have equal corresponding angles and proportional corresponding sides. And if they are similar, we can use the symbol, a tilde, a wavy line, to show the relationship between the shapes. We have to be careful in choosing our corresponding sides and vertices. So if I said triangle ABC and compared it with triangle XYZ, the way that I've written it down here is I'm choosing a correspondence where the letters are in the position of what they correspond to. This A is first. I'm showing that it's corresponding to angle X. But angle A is not equal to angle X. The notation says that they're not. This is one arc and this is two, angles that are of different measure. So in this way of choosing the correspondence, these triangles are certainly not similar. We have the similarity symbol with a line struck through, say not similar. But if we can choose any correspondence, any way that angles and sides correspond to one another that works, then the triangles are similar. We wouldn't try it this way and then abandon it saying that the triangles are not similar, because we could show the triangle ABC, if we choose angle A to correspond to angle Z, angle B to correspond to angle X, and angle C to correspond to angle Y, then we have equal corresponding angles. And if we add side measures, we show they're proportional and say that these triangles are similar. I have a double-headed arrow here to suggest that if you know that triangles or any shapes are similar, then it leads or it follows that the corresponding angles and sides are the corresponding angles are equal and the corresponding sides are proportional. But we can go in reverse. If we can establish and prove that corresponding angles are equal and corresponding sides are proportional in the shapes, then our conclusion is that they're similar. It goes both ways. So how much information do we need to prove that triangles are similar? We could certainly have all of the angle measures and all of the side measures and use that information to prove or not prove that they're similar. We could justify that they cannot be similar if we're given the right information. But we don't always have all of the angles and sides. Sometimes we only have a few bits of information. So what information is enough? Well, with some exploration, there are 3 configurations of information that is enough to prove similarity. AA for angle-angle. And the tilde is reminding us that this is shorthand for a theorem called the angle-angle similarity theorem. Having 2 corresponding angles and knowing that they're equal is enough information. We could also have 2 sides, 2 corresponding side pairs, and show that they are the same, they're proportional, they share the same ratio, and the angle in between the given sides, and that would be enough. We could also have all of the sides of the both triangles and show that they're all the same proportion, and that would be enough. To get a visual of this, imagine that we're trying to justify the relationship between these 2 triangles, and we only had one corresponding angle being equal. This is not enough information. We could have wildly different side measures and still have this one angle being equal. It would not be enough information. But if we have another angle, then this is going to force all of the sides and the remaining angle to be proportional, and the angles will be equal. This is enough information. We could also be given the measure of A and a corresponding side, capital A. Forming a ratio would look something like lowercase a over uppercase a. That's a ratio of corresponding sides. We need more than one pair of sides. We could be given another side in both triangles that correspond and create the ratio lowercase b over uppercase b. And if these ratios are equal, then these corresponding sides are proportional, and that's a part of being similar. We could also be given the third side and make the ratio lowercase c over uppercase c. We want to be careful of one situation. Side-side angle. We have 2 sides, and we have an angle. But the A is not in between the S's. In this case, this would be like having a triangle and comparing it with another one, wondering if they're similar, but the information that we have about these triangles is that we have side measures to form a ratio with, in this case 1 over 2. We have another pair of corresponding sides with measures that we could form a ratio with. This would be 2 over 4, and it could be shown that 1 over 2 is equal to 2 over 4. They both have a common ratio of 1/2. And we could be given an angle measure and know that it is equal to this corresponding angle. This is the side-side angle situation. Notice that side lengths that we're given work, but the angle that we're given is not in between. This is not enough information to prove that these triangles are similar. And the reason for that is because there is a third triangle that has the same information. That means equal corresponding angle, proportional sides, but this triangle is a different shape. Side-side angle is ambiguous because there's always 2 versions that share the same information but are not the same triangle. So it's not enough information that any 2 are similar to each other.